Yeah, that is your get out of scribing part.
Tail, how do you feel about scribing? Tail?
Well, the people are pretty good at avoiding eye contact.
He's good at saying no, yeah. We picked on Gabriel yesterday.
We did.
Yeah. We still don't have one. Thank you, Brian Trammell. It's bad when we have to fall back to IAB members to scribe. That's not a good sign. Yeah. Well, Gabriel did it last time. Thank you again, Gabriel. It's very kind. Never again for IASA?
You should have saved yourself for us.
I mean, I can play the clip from Yes Minister where he explains that those who write the minutes get to write reality. That should be an incentive for some people here. I don't know. Yeah. Okay, so Brian is scribing. Thank you, Brian. Our minutes are on the Etherpad, linked from the agenda. Yes. Oh, I need to play that clip for you, obviously.
If you want to help Brian, go on the Etherpad and correct names and stuff like that.
We had a problem with the Etherpad yesterday that once it got over about 20 people in the Etherpad, it got pretty melty.
Oh.
So if you're not helping, don't go on the Etherpad. Thank you.
Thank you. Yeah.
Okay. Well, welcome to. Our plugs are out of sync. Okay, let's fix that. Welcome to Quic. This is our second session. This is the Note Well statement, as we've said many times before. These are the intellectual property terms under which you participate. So if you're not familiar with this, please go and have a look at IETF Note Well on your most convenient internet search engine. It's important to understand this. Can everyone in the back hear me? Is this a good volume? I need positive. Okay, good. Thank you. Because, yeah.
There's some people in the Jabber room that complain about the audio. If you're in a Jabber room and you have audio trouble, would you say something there and we'll try to fix it with Meet Echo? In here, it's fine.
I'm going to fix this. Likewise, just a reminder, as we've done a few times recently, we expect this to be a professional environment. If you have issues that you can't handle by talking to the person who you're concerned about or by talking to us, your chairs, we also have an ombuds team. I said it right. Who can handle issues, especially regarding harassment. And those are the folks at the bottom of the slide. So today, I will send the blue sheets out in a second. We have a scribe, thank you, Brian Trammell. We have a Jabber relay, thank you, Ben. And Agenda Bash, session 2. This is actually a little out of date. We're going to take the item that we postponed yesterday, Martin giving a summary of the changes by the editors and put that at the top of the agenda. Then Ian's going to talk about loss recovery. John's going to talk about connection migration. And we're going to talk about the third implementation draft and what it might contain. And finally, if we have time, we'll discuss any open issues. Any other items, agenda bashing? Okay, great, let's start. So, Martin, you're up. On their way.
Right, so this is going to attract some discussion, I predict, like everything. You put a target in front of the bull and it just runs. Next. Okay, this should be history for people. This is what people were concentrating on during the hackathon, which was draft 7. We didn't do a lot in that draft. We just made a few tweaks. We use ASGCM to protect the handshake packets. We got rid of the 1RTT long form headers, packet forms. And there's a bunch of changes that don't quite complete the discussion about closing, but got most of the way there. And I've got a little bit more on that following on from that because we've made a few more changes coming on from that. We shifted where the stateless reset token was. I don't know how many people have actually implemented that one. And we removed timestamps from ACKs based on the discussion we had at the previous interim. Next. So closing has received a lot of attention in the past little while. The base of these changes was in draft 7, and we've made subsequent changes in draft 8. The basics here is that there's 3 basic modes of operation. One is there's an idle timeout that both sides advertise. When that timer runs, it's actually a negotiation. I say X, someone else says Y. The minimum of those 2 is the time that the connection can remain idle before it starts timing out. There's also the immediate close, which we decided would be used for the graceful shutdown case. So the application's done with the connection, or it detects an error, it sends a message. We have 2 of those now. Look at the draft for the details. And then there's a stateless reset. So a lot of the discussions sort of focused on this, the states during these transitions. We have essentially 2 states now, and there's a pull request that needs a little bit more work before it goes in, but essentially we have the one timer, and then you transition between 2 states in that timer. The first state is only really triggered in the case where you send one of these close messages, and that's the closing state. Pick better names, people, it doesn't really matter. In that state, you don't send any packets except for a close message in response to receiving packets from the other side. So in case your close message was lost, you provide more of them just to make sure they get through. The second state is the draining period, which is essentially you keep your state around for a little bit of time to make sure that no incoming packets for that connection, reordered packets, those sorts of things. Make sure they don't get treated as if they were new connections or anything like that. You can associate them correctly with the connection state and throw them away properly without triggering any sort of other machinery. There's a bit of discussion about that, and I think Christian raised a few points about, well, what state do you actually need to maintain in each one of these things, because there's not a lot of information you need to maintain in order to make these decisions correctly. So there'll be a little bit more to add on that in the next draft. Expect to see that in the next little while. The pull request is in motion. Next, I'm just going to go through these in a little bit more detail with nice ladder diagrams. So timeouts, relatively straightforward. You have an agreed timeout period. When that timeout period elapses, both sides go into this draining state. And the reason that both sides go into this draining state is that their individual views of when the period starts is skewed based on time that the packets take to deliver. Maybe there were spurious retransmissions or something like that that caused the 2 sides to have some slight disagreement. Current draft says 3 RTO. That's also up for negotiation. There's some discussion in the doc about how you might shortcut that in certain circumstances. Next. Immediate close is more interesting. I've shown one of the more complicated scenarios here. So A detects some sort of error and sends a connection close. That connection close could be lost, and I've shown that disappearing into the ether in this case. B continues on happily, ignorant of the fact that it's generated some sort of error, and sends packets to A. A, because it's in this closing state, detects that, oh, I've got an error on the slide. But it sees one of those packets coming in and sends a connection close out. So this is essentially loss recovery for the close thing. The amount of state that A is maintaining in this case is pretty minimal. It can actually just save the packet that received, and there's some question about whether it even maintains decryption keys for the incoming packets. But that's something we're going to sort out. B can send a connection close to sort of shortcut this whole process. We had a bit of discussion with implementers about this one, and they were concerned that in these shutdown scenarios, there wasn't any way to sort of guarantee termination in a reasonable period of time. So they were having test cases that were sort of in this sort of trailing state. And if you're operating test cases in a sort of lossless environment, being able to send a close in response to a close is actually quite nice, because then both sides enter a state where they're essentially done and there's no more packets needing to be exchanged. So we allow that to happen once. but we don't allow that to be repaired. Otherwise, we get into a ping pong situation. There's a bit of debate about this particular point as well. Christian suggests that we could use a particular error code for this situation and allow B to continue sending, but I don't actually think that's necessary, but we haven't resolved that particular part of the conversation. The error on the slide is that once A has received a positive indication that B is closing, it doesn't need to send connection close anymore. And so it enters the draining state also, and both of those just quietly go away at that point. Next, well, it's actually in the text there, but never mind. Stateless reset is really quite simple. The server doesn't maintain state, so if it receives a packet that it doesn't know about, it can send a stateless reset, and the client then enters a draining period just in case this was a reordered packet or something along those lines. Pretty simple. Next. Ooh, no questions. I'm just going to rush through these in the hopes that no one says anything more. Right. So we decided to do both Plan A and Plan B. Those people who are familiar with the wonderful Plan A, Plan B discussions on WebRTC will enjoy that particular reference. So we essentially decided that we'll use the two lower bits on the stream identifier to identify essentially 4 different types of streams: bidirectional, unidirectional, client, and server, the full matrix of them. When we looked into this, we discovered that stream 0, which we use for special purposes, was being allocated, I think it was unidirectional server or something like that in the first iteration of this, and we managed to get it to bidirectional server initiated, but then that didn't make a whole lot of sense because clients initiate this stream. So we flipped the bit, and now it makes a little bit more sense. So people who actually implement this using a standard stream machinery will be able to say, well, this is just a bidirectional stream that the client initiated, and they can use all their standard stream machinery without special logic other than the necessary special logic in order to handle this. Consequence of that is now that we've flipped the lowest bit. So anyone who's used to saying that clients initiate requests on stream 3, for instance, will now find that it's stream 4 instead. And it's 4, 8, 12, 16, because we now have more bits consumed. There's new state machines coming. I think we're going to go through in a little bit more detail about how the individual sides of a stream transition through state. So we'll have a send side state and a receive side state, and it will be up to implementations to synthesize a state if they want across a bidirectional stream, if that's at all interesting to them. But I don't think we're going to spend a whole lot of effort on that. There's a table in there that sort of maps to the HTTP2 stream states, but it's imperfect because Quic doesn't have some of the properties that HTTP2 does. Next. We changed all of the numbers. Previously, we had a mix of different things for all of our different numbers in the protocol. We had 8 bits and 16 bits and 32s and 64s, and then we had these weird things where they had flags over here, and it was either 8, 16, 12. There's many, many different ways in which we could represent a number, especially like the bespoke 16-bit sort of floating point format that we had. That was great. It fit for purpose, but just another format that we had to deal with. So now we just have one. It's variable size encoding. We take the first 2 bits, and that encodes a size, 8, 16, 32, 64, and the remainder of it's a big endian number. It leads to some interesting maximums for these, but it actually works out pretty well. We decided to also move this to the HTTP mapping. Conveniently, it has the property of allowing us to remove continuations for header blocks, which was something that people really, really hated in HTTP2. And that is no more. It also means that in most cases the frame sizes will actually be smaller. HTTP2 frames have a 3-byte length, I believe, And now, for the most part, we'll have 1s and 2 byte lengths, which is quite nice. So I did not check those numbers particularly. That's just examples of things that you can do. But yes, 6, 14, 30, and 62 are the new numbers. Next. A bunch of little things. We decided that max stream data can just use octets rather than kilobytes. We have a Pong frame. There's some address validation stuff that's in the draft now. So someone who detects connection migration can sort of probe that particular path and see that there's actually someone live on the other end. Return routability checks are quite nice. We renamed the packet types, which doesn't seem like it's much, but we also removed the separation between client handshake and server handshake packets. They no longer have a different packet type. I think there was one other thing that I added to this slide, but I've forgotten. So there's probably something more in here, but I think these are the ones that are coming. Is there anything else coming, Ian? I'm sure there is. We're going to fix the packet number and the connection ID thing and that sort of thing, but I don't think that's really all that important. Yeah, it's all little stuff. Yeah, and that's all I have.
Mike Bishop, I think we had talked about putting the push ID stuff on the slide as well.
Right, and I did in my own copy and didn't upload the changes. My apologies. So Mike and I have been talking about moving to a model where requests in HTTP have their own identifiers at the HTTP layer. So when we made some changes for push, we created this notion of a push identifier. And so when you make a push promise, it has an identifier that's explicit at the HTTP layer. And then when you provide the response in that unidirectional stream that's coming back now, it includes that identifier. Currently, we identify requests by their stream identifier, their Quic stream identifier. And the suggestion here was to provide an HTTP layer identifier that's explicit at that layer. And it allows people to implement transports that don't expose the stream identifier to the application layer.
Totally quick question on the format of the identifier. What kind of identifier is it?
A number, and I imagine it's going to use that number encoding that we talked about previously.
Okay, I ask because if you wanted to make it trivial to use the same mechanism for something else like DNS, DNS uses QName for this exact purpose, and having the identifier enable that would be handy. It's certainly possible to map a QName into an identifier that is a number and to get around this problem, but I just wanted to raise the fact that in other protocols using a string might be handy.
So this would not be generic. So this would be HTTP specific.
So you anticipate that if a different protocol wanted something similar, they could use a different format?
Yes.
Okay.
Yeah. So DNS might use its QName or something else. It doesn't really matter. They have their choice. This would be specific to HTTP, but we'd be establishing, I guess, a best practice in a sense of saying, don't rely so much on the underlying identifiers. Make your own identifiers for this. And I think several people have expressed that this is a pattern that they'd like to see. Ronnie.
Ronnie Evan, about the closing, all these closing things, I mean, there will be some difference between unidirectional and bidirectional that you need to put in the
So the stream states are different between bidirectional and unidirectional, but when you actually look at the independent state machines, the primary difference between unidirectional and bidirectional is that there's an opening transition for a bidirectional stream when the paired side opens. So if one side opens on a bidirectional stream, the other side is implicitly opened to match, and that's the primary difference. Beyond that point, there's not a lot of difference there. The things that the things that sort of come up as a result of that is if you are blocked on a particular stream, you might send the stream blocked thing. That will cause the stream to open in the opposite side, in the opposite direction. Those sorts of things are where it gets interesting. But other than that, once you're in steady state or you've transmitted all the data, all the states are exactly the same. They close the same way, and everything. That we have independent read and write close. We don't have an atomic close both directions at once, because that just doesn't work in the protocol. All right. I saw some frowns, but we can talk about details offline. I'm sure that there'll be more words in the draft very soon.
I was going to add to that sorry, Ian Sweat, Google. Martin's PR that's in flight and hopefully will be landed soon does a very nice job of like clarifying all this. So either if you're super interested in like stream state machines, look at the PR, and if you're only kind of interested, then like wait for 08. Yeah.
All right, thanks for that. Next up, we've got loss recovery with Ian.
Do I need to? Oh, I don't have. Do I have to eat this mic as well?
A little bit, but not as much as yesterday or the day before.
Can I move it? Oh, but I can't move outside the pink box, right?
You can, but
Be scolded. I understand. Okay. Okay. Next slide. Unless, I can read the slides, but. So the goal of loss recovery in Quic is to minimize the time it takes to repair data in lost packets and ensure the connection makes consistent forward progress. At least those are kind of how I think of the two goals. And the one kind of quirky non-goal, especially relative to TCP, is the recovery draft tries not to spend too much time telling you what you have to send in those packets. So we'll go over kind of why later, but like, unlike TCP, the ordering of what you retransmit is a lot less important. And so the recovery graph more focuses on like when you should be sending and when you should be declaring loss, not like what is in those packets. Next slide. So some of the principles: packets are never retransmitted, information in them is. So yeah, focus on what to declare loss, not what to send. So another principle is you wait until you actually have information in order to make a decision. So an example is we don't mark packets lost until an acknowledgement for a packet that was sent after it is received. Kind of makes sense, but makes things a lot simpler. We also avoid undo in general, in particular FRTO, if you're familiar with that, which is the process where you might do a retransmission timeout and then decide it was spurious afterwards and then try to like unwind your state. We don't do that because unwinding state is complicated and bug prone. Instead, we just wait until we actually know whether the RTO was spurious and then adjust the congestion window at that point then. So, and in the meantime, we basically like clamp down the congestion window. So it's not actually, it's like basically temporarily clamped down, but we don't actually change any of the congestion control state. So it turns out to work out a little bit simpler. Next slide. Notable differences from TCP. Quic doesn't have retransmission ambiguity because technically no packet is ever really retransmitted. It is, the same frames may be rebundled with a new packet number, or slightly different frames may be rebundled with a different packet number. Acknowledgements can contain as many act blocks as space allows, at least in the current draft, because of the new varant thing. So it used to be 255, which is already more than enough, and now it's essentially unlimited. Acknowledgements are irrevocable. So once you hear an acknowledgement for a packet, that means the peer has received it and processed it, which is the next item. And from that point, you don't have to keep it in your send buffer or any other sort of things that you might have to do for TCP with SACs, which are revocable. And recovery ends with a packet number, not a sequence number, after the largest outstanding packet is acknowledged. So this is sort of a subtle point, so I'll try to elaborate on it. In TCP, recovery is the period of time you enter when you first experience a loss. and it lasts for approximately an RTT. In TCP, however, in order to exit recovery, you must have packets that are sent sort of like, essentially all the lost packets have to be filled in, and your sequence number space has to be filled in. So this is sort of in sequence number domain that you have to exit. That may actually take multiple RTTs to get you out of recovery. And for a number of circumstances, particularly with like high loss circumstances when you have multiple retransmissions of the same packet. In Quic, it ends when you have a packet number that was sent when you, the first packet number sent after you enter recovery. When that is acknowledged, you exit. So one benefit of this, on the one hand, you exit recovery faster. So that could be a pro or a con. But one distinct benefit is that if you are continually losing packets over multiple round trips and the loss rate is very high, Quic will more rapidly reduce the congestion window because each time it's a separate loss event and there's a multiplicative decrease. Whereas TCP will commonly only reduce the congestion window once, even though it might take 3 or 4 RTTs to repair all these losses.
I'm just trying to make sure I understand this because it seemed a little subtle. And
yeah, this is totally subtle.
A diagram might have helped.
Probably, yeah. Well,
oh, they really did. Fix
I don't
it.
want to dwell on this, but I do want to like highlight it for those who are like familiar with the topic. So,
okay, maybe I'll just ask you later.
Yeah, I didn't make a diagram for this, unfortunately. So.
Especially apparently Trammell students running this for me, so I can just pretend I don't know.
Yeah, it's not a super critical issue, but it is an issue that might not be obvious if you're just reading the documentation. Next slide.
Nope, sorry.
Okay, so now I'm actually going to step through the 2 types of loss detection in Quic. One is ACK-based. So this is when you receive an acknowledgement for a packet that is larger than some previously sent packet. So I receive an acknowledgement for 6 and maybe not for something below 6, as this example will show. And then the other type is going to be timer-based. So like tail loss probes, retransmission timeouts, and the such. So let's step through the FAC example. FAC stands for forward acknowledgement in TCP. This is the general style of loss detection where you look at the distance in kind of packet numbers of how far the gap is, opposed to the number of actual dupacks that you receive. So in this case, it's basically a simple matter of math. Is we compute like whether I have a packet number that is 3 or more above a packet that has not been acknowledged. So next slide. So the receiver receives 1 and 2, sends an acknowledgement frame to the sender. Next slide. 3, 4, and 5 are dropped, so 6 is still in flight. The receiver, next slide. Receives 6 and immediately sends an acknowledgement for 1 and 2 as well as 6. Next slide. And when that acknowledgement is received, the receiver declares 3 lost. So because it's a packet distance of 3. In this example, nothing is immediately retransmitted just because I don't want to really kind of go into that at the moment. But yes, if 3 was retransmitted as 7, it could be used to recover 4. So I'm going to go into a different example, which is why I'm not going to retransmit 3 just for the sake of argument.
Just to disambiguate here, you're saying that the packet number 3 is lost, not 3 packets are lost.
Yes, the packet number 3 is lost. Is declared lost by loss detection. Thank you. Next slide. Early retransmit. So early retransmit, as with TCP, kicks in anytime like the largest outstanding packet that is going to be acknowledged is acknowledged, and there are packets underneath that have not been acknowledged. So this is an effort to speed up loss detection in cases when you have losses near the tail. So your reordering threshold is large enough that the very last packet was acknowledged, and the packet before it was not. So you're not going to declare it lost immediately, but at that point, you're not going to get any more information back about it. So we take the approach in Quic of doing what the Linux kernel does, which is to set an 1/8 of an RTT timer, and then when that timer expires, declare packets lost. So as you can see, 6 has been acknowledged, and we're still waiting for 4 and 5. The sender is setting a timer. Next slide. When the timer expires, 4 and 5 are declared lost, and we're done. Next slide. Timer-based loss detection. So timer-based loss detection is probably a little more different from TCP than the regular fact style and early retransmit cases I just ran through. Timeout packets do count towards bytes in flight. So in Quic, bytes in flight can exceed the congestion window for a period of time. So again, that kind of ensures that you actually get a correct congestion control signal, even if you're in the timeout sort of mode. Timeout events do not immediately cause packets to be declared lost or change the congestion control state. So essentially the idea is, I don't know anything. All I know is I haven't heard anything. So that could mean I have, a temporary Wi-Fi outage, or it could mean just like, suddenly a bunch of packets are in a queue and, everything's fine. So I'm going to wait until I actually know something to adjust the congestion window or declare anything lost. So therefore, yeah, the CWIN does not change during these periods of time. And that's true for all 3 types of timeout I'm going to walk through. Next slide. So the handshake timeout is set to the RTT, which is either a measured RTT or initial RTT, times 2 to the number of timeouts plus 1. So essentially, if you have a initial RTT like Quic does of 100 milliseconds, then the first timeout for a handshake would be 200 milliseconds, and then 400 and 800 and so forth. It's set from the last sent handshake frame, so it's kind of like the most recent handshake frame. And you retransmit all unacknowledged handshake packets. So this is a little bit more aggressive than the other timeout modes potentially, but the idea is that the handshake should be relatively small, and additionally, it's very important that it actually completes, because otherwise you can't really make any progress on the connection. And yes, the expected RTT, if you don't actually have an RTT sample, as for the very first packet, is based possibly on previous connections. If you're doing zero RTT resumption, it could also be based on other environmental factors, like I know I'm on like a 2G network, so I can set it to 2 seconds. I mean, certainly there are tweaks that can be made there. Next slide. Tail loss probe. Tail loss probe is from an informational draft that was published by some folks a few years ago. Is default enabled, I believe, in the Linux kernel. I believe it has now been implemented in BSD in combination with rack. So it's fairly widely used in the industry, but it is not an official RFC. So these constants are all kind of taken from the tail loss probe paper, but the idea is tail loss probe is set when you haven't heard anything back for 2 smooth round trips, or in the case of if you only have 1 packet outstanding, 1.5 times the smooth round trip time plus the delayed ACK timeout. It's set from the last time you sent a packet, so it's just basically like I haven't heard anything or sent anything in this period of time, and you only send 1 packet. And Quic by default does 2 in a row of these before going into retransmission timeout, at least at the moment. The draft for TLP specifies 1 or 2 is recommended. One could reasonably choose 1 as well. Yes, Ted?
Ted Hardy, just a quick clarifying question. For retransmittable frames, do you also include things like the ping and pong frames, which are not themselves retransmittable, but where the idea of sending a new pong frame might fit the same bill?
I would say that's a yes, but you make an interesting point. The original ping frame was retransmittable because it actually had no payload, and we've kind of tweaked the meaning of the ping and pong frames to be a little bit different, but the short answer is yes. Okay. Essentially, it's anything but an acknowledgement. Anything that you actually need to make it through the path.
Makes sense, thanks.
Yep. Next slide. Retransmission timeout. So this is the classic retransmission timeout formula. You have smooth round trip time plus 4 times the RTT variance. You also have a min retransmission timeout. We, as with many of these other constants, we are currently using the Linux default, which I believe is 200 milliseconds, and it has exponential backoff. So Quic, at least currently, is setting its retransmission timeout a little bit differently from TCP in the sense that it is setting it from the last sent packet with retransmittable frames, just like the tail loss probe, not the kind of first packet. And just like TCP, we're sending 2 packets. So if you're doing, tail-off probe twice and then retransmission timeout, say once or twice, at some point, one of 2 things is going to happen. Either the connection is going to time out because you just get black holed, or eventually you are going to receive an acknowledgement. When you receive an acknowledgement, at that point, in the case of the retransmission timeout, you will go down to the classic minimum congestion window, which we default to 2. If it turns out the retransmission timeout was valid, i.e., the retransmission timeout packets got acknowledged, but nothing previous did. Similarly, if any of these packets are acknowledged, like the tail loss probe or otherwise packets besides the retransmission timeout, normal loss recovery will kick in. So even though we don't declare a packet lost when we do a tail loss probe, any previously sent packet, if the tail loss probe packet is acknowledged and it hasn't, the previous packets haven't been delivered, then yes, they will be declared lost just like normal. So mostly this relies on standard ACK style. The whole idea of these timeouts is basically to get you back into the mode where you're using the standard ACK style fast recovery. Next slide.
Ian, Gori first. My name, not your name. Yeah, that's good. Right. It seems to me like you send a lot more after RTO expiry than TCP would in the first round. Is that right? Or am I misreading?
After retransmission timeout?
After the first RTO expiry, you seem to send several packets rather than one.
I think my understanding of the Linux implementation is that it sends 2 instead of 1 for a retransmission timeout. Am I wrong about that?
Praveen, I think you're supposed to only send 1, so the 2 packets are actually confusing to me. And I assume mince event is also 1 after timeout?
I believe we are setting it to 2 because I think that's what Linux is doing.
Jana Iyengar, yes, TCP is supposed to send 1, but the cost of retransmitting after a timeout is incredibly high. And the whole point of sending 1 packet makes that 1 packet incredibly fragile. If you lose it, then you have to wait for twice the RTO before you do any sort of recovery again. So sending 2 protects you from that fragility. I think there's value in considering this for TCP as well, to be honest.
So yeah, I'm going to actually go to the constants in the next slide, but I think there definitely are things here that are taken as a model from what Linux does as defaults, and not necessarily from the RFCs. And so the constants are and formulas are sort of a mix of the 2.
That is okay, but I think whenever we are deviating, we should probably document it.
So this is perhaps Jana Iyengar, this is perhaps an interesting question. Some of the constants that you will see here are also aggressive because we found them to be quite useful. And Quic is definitely driving towards, like the handshake timeout, for example.
Next slide. This is relevant to this. Thank you. Okay.
Yeah, there you go. Thank you for doing that. I mean, and some of them aren't even what Linux does. One of the things that is TLP. In Quic, we do 2 tail loss probes before we go to an RTO, whereas in Linux, it's actually 1 TLP before we go to an RTO. And some of this is designed to be, it is necessarily trying to be more aggressive in terms of recovery, but still safe because the fundamental mechanisms are still the same. I don't know how to think about this in terms of comparing with TCP because the mechanisms are still the same, and we don't anywhere in here, we aren't required to follow TCP's specs, but we are referring to it.
The only concern would be if any safety properties are being violated, because the timeout basically tells you that the network is in pretty bad shape. So I would suggest that yes, I mean, if 2 is what we're recommending, we should put it there, but it would be nice to note that if a conservative implementation may choose to do 1. That would be my feedback.
The only reason, so we should discuss that. I think the constants. So a big part of this is basically discussing the constants. I think those are in my mind what I expect that we will end up discussing. But as you said, one of the higher order points that should be clear from here is that the safety properties are not getting violated. We are pushing the constants around, but the fundamental mechanisms are still the same.
Yeah, that makes sense. I had a question on the tail loss probe
Sure.
slide.
Can you go back, Reese? Well, yeah.
I think one slide back.
One more slide. Thank you.
The K delayed act timeout, what is the value that we're picking?
That's in the last slide. Go back, forward 2 more slides. Is 25 milliseconds by default. We chose a value that was lower than I think what most operating systems are currently defaulting to, although it's possible some are picking this value, partially because it made a variety of congestion control situations particularly, basically made delayed acts less problematic from like doing things like PPR especially.
Yeah, because this is the sender picking the value when it's doing tail loss probe. One of the deficiencies in TCP was we, for example, can't assume that the other side is doing 50 milliseconds, and we have to pick a worst case value of 200 milliseconds. So this might be a useful transport parameter to negotiate so that we can pick the right value that.
I would agree. That's what issue 912 is. Actually, I wanted to get a feel for the room because this is like one of those things where I would very much like to move forward with this, and I don't think there's a lot of objection. But I think for once I have everyone, the right people in the room. Would anyone object to communicating the peers, maximum act delay in transport parameters in Quic? Is there any reason we would not want to do that?
Gori first again. Didn't we talk about this in TCPM, and it's still an open issue there? So we can talk about it here, but we can talk about it there as well.
Jana Iyengar. So this is perhaps a matter of process, and the chairs can direct this. With the constants and with the mechanisms, one of the decisions that we made early on was to say that this is going to be a standalone document, which basically cites other stuff. But this is going to be its own standards track process and not going to
They'd be informative references, not
right. There'd be informative references, but we are not going to live with the same musts and shoulds that we have in TCPM, in TCP, in RFC 2581 or 5681, and that's part of the reason why I think that folks who are familiar with the documents, relevant documents, should be engaged in the standardization of this document as well. That said, the constants here are different. As Ian pointed out earlier, some of the mechanisms are subtly different, and that will cause some constants to change. We are also chasing perhaps a slightly different target, which is latency, and so some of the constants are a little bit more aggressive. And as Ian pointed out, they borrow not just from the specs, but also from current practice. So this may be something that can feed into the TCP process that maybe can be used to change constants that we use for TCP as well at the IETF, but this is a standalone document, and I don't know if that conversation should be, hey, can we move this conversation to TCPM or somewhere else? I think we should have the conversation here as well.
Yeah, I agree that the conversation should happen here, but we have a lot of TCP people in the room. That's why we specifically said we're going to talk about this stuff here and not in Melbourne, where that might not be the case. So I want to echo Praveen's suggestion of actually documenting the differences to the TCP values, and maybe even put an appendix in or sort of describe the motivation for the differences, right? Because otherwise, we're going to keep getting those questions over and over.
So
and we can always rip that out if it becomes useless by the time we go to RFC. But for now, it might be useful to explain why these are different instead of just picking them out of a hat.
That's completely fair. Follow-on question: when you say the differences on TCP constants, are we talking about the differences on TCP constants in the RFC stream?
Yes.
Then a tail loss probe doesn't exist in the RFC stream.
Right. Well, it does. It does not as standards.
Well, it's an expired draft.
Really? We never did that? Okay.
Yeah, that's my point.
Yeah, well, so informationally cite the expired draft, but I think sort of there's sort of two set of constants that congestion control people sort of know about, right? One is what the RFC says, and then there's what Linux does. That's basically the two sets of things that people are familiar with, and I would sort of even go as far and say, if you pick the Linux one over the RFC one, say why, and if you pick neither, especially say why, and if you go with the TCP one, you can sort of assume that everybody knows why.
That seems fair, but I think instead of saying Linux, we should probably say standard implementations, because there are other implementations too.
And I didn't catch it. Can you say it again?
I said instead of specifically referencing a Linux implementation, I should say typical implementations pick value XYZ, and we are deviating from that because of reason.
Sure. I mean, the only sets of values that are easy for people to look at are from the open source ones, right? And I don't know how to. If you're willing to contribute text about what Windows might be doing for a constant, then that's fine too. But I think we're running into danger of having like a comparison matrix of what different stacks are doing in this document, which is also probably not going to be super useful.
Yeah, fair enough. The RFC deviations are pretty straightforward, but the ones that are not in RFCs, yeah, I think like picking a typical value that's from the Linux kernel seems fine to me.
Yeah, I mean, I'd be happy to have your help, Praveen, if you wanted to contribute some to that section. So there's a small section there that sort of says basically like most of these were yanked but from Linux except for these 2 or 3, which is pretty terse. So I mean, we could certainly go into that and like elaborate a little bit more if it's helpful to people.
Janang, I just one last comment on this thread is that I would encourage people who are reviewing this and reviewing the constants to not simply look at the constants, because the mechanisms can be subtly different. As I said earlier, the safety properties are not violated, but the mechanisms are definitely, in general, as a rule, you can assume that they are subtly different.
And that would be an excellent point to make in the document as well, because I think text like that currently is sort of lacking. It's very detailed in terms of the pseudocode and the constants, but the actual motivation is at the moment not there yet.
That's fair.
While I'm speaking, so I also got some feedback that people are confused that all the other drafts are at 07 and this is at 06. So my suggestion would be we try to keep the base draft set. Sorry?
It's at 07.
It showed up in my data tracker and in Jörg's data tracker, it's at 06. So I'm very confused.
I was
anyway,
looking at.
Let's continue.
Yeah. Okay. There was a question about the max hack delay in TCPM. Yeah, so that's a deficiency in TCP, and I think we have an opportunity here to kind of actually explicitly communicate the value, so we can do the right thing with tail loss probe. The other question I had was this default RTT, the 200 millisecond handshake timeout. So I assume that things like caching the initial RTT in the path and using that as the signal for the actual timeout might be a good suggestion to put in there, because satellite links, this might be way too aggressive.
Yes, that is a suggestion. I think currently it suggests you basically like cache the value for a server when doing 0 RTT. That's not quite sufficient for some circumstances, because if you're on a very long RTT link, it may turn out that like some new server you've never contacted before like also has a very long RTT. So I mean, I don't have enough implementation experiments with the latter part, but certainly the former approach of just saying like, last time I went to www.example.com, it was X. We use in Quic and seems to work well and is recommended in the text.
Yeah, my name is Michael Schaaf, speaking as TCPM co-chair. So I would strongly back documenting any deviations from what TCP does, because it's very simple. You can easily get faster than TCP if you make all the constants more aggressive, which is fine, but you definitely have to document that, because if that's at the end of the day what speeds up things, then you have to at least document that. And other than that, it would perfectly fine if you bring these things to TCPM so that we can understand how we can build equivalent concepts in TCP as far as they apply with the protocol that we have.
Yeah, thanks. I will say, actually, I didn't bring this up before, but I think Rack tries to end up implementing like a huge number of these principles. So it ends up being like quite similar, at least conceptually.
So Gary, first, I think the algorithms are going to be different here because there's good reasons, because your mechanisms are different. So the timeout constants are going to be different, but then I worry about whether the protocol could be more aggressive, which is kind of repeating, I guess, what the previous speaker says. But we need some way to get a handle on this. Just a matrix saying you're 100 milliseconds, it's 200 milliseconds doesn't help. We need somehow to understand how it will compete in a queue, and particularly in really strange environments where you've got wireless mangling up one side or something. So I don't think this is an easy comparison, but if it's going to be more than experimental, then somehow we have to figure this out.
So my hope is that like next year we'll have, or early next year hopefully, we'll have implementations that you can actually run some bulk data through. And those of you with students might throw some at this and get some papers out of it and come back and show the results from experiments or simulations or what have you, so that we can have a discussion, maybe in ICCIG or something on Quic versus TCP and what does it look like.
I like that. Thank you.
Yeah, that's a great idea.
That's a great idea.
Hey, so I actually got up to address your question comment about should we expose my settings to the other side. during the handshake.
Your what?
My constants to the other side. So you suggested.
Well, it's particularly one constant.
Well, like once we decide to do one, others might be convenient as well. But let's just focus on this one.
Sure.
The specification doesn't say you have to do layac at all.
That's true.
And it also doesn't say you have to have a ACK that is implemented by doing a single timer that pops and then you pass in the ACKs. So one thing you might, for instance, do is you might consider, you might consider the number of packets that you've already received that you've not yet act as pressure on when you act. Now, I'm not saying any particular thing you should do. I'm just saying that I'm worried about codifying the notion that this opinion about the receiver's algorithm in the protocol, because the receiver might not have a timer, right? And so what is he going to say then?
I think if the receiver doesn't have a timer, probably things are not going to work super well.
Well, no, but let's say you might have a timer that was like 25 milliseconds divided by the number of unact messages you received. So what would you? There's no way to express that, right?
I guess my goal there would be to return the maximum timeout. So I don't think we need to communicate the full acknowledgement algorithm. I think I agree that's massively too complex, but there needs to be some bound on you can set a timer for this, and if it's been this long, you probably waited long enough. That's all I'm really looking for. And
Okay.
right now in TCP, most implementations I believe now either use 100 or 200, and yet I think the RFC says 1 second, and so we're basically if you're conservative, you choose 1 second, but that's crazy. So no one does. And so they choose some smaller number and hope it works.
Sure. Well, I guess
which is nuts.
Then it's important to write this text very carefully so it doesn't so it doesn't end up having you say things that don't make any sense.
Yep. I agree.
Brett, Jordan, I apologize for my ignorance in advance, but I'd like to shift gears a little bit. So from my understanding, that all of the ACKs for Quic, as we currently have them defined, will all be inside of the encrypted tunnel.
That's correct.
And so I'm interested to know how we plan on enabling the network operators to actually help when things go wrong. So when you run a large network, you may not own either end, like the client or the application.
This is not the document where we have this discussion.
I know.
Please.
Okay.
So
Were you here yesterday? Probably.
Yeah, I was.
Okay. Well, okay. I don't have a good answer. Yeah, I think this is not the document for that, unfortunately. So
okay.
Thanks.
Jana Engar, I wanted to respond to something Gauri said earlier, which was around comparing this with TCP and so on. I think it's fantastic. We should do it at some point and try to understand in more detail how friendly these constants are. And Michael said something about how Quic's benefits are coming from these constants. Part of my response is absolutely Quic's benefits are coming from some of these constants, and therefore these constants should get transplanted into TCP where they are useful. But the higher point I want to make still again, and I'm to some degree repeating this point, is that there are subtle differences between Quic and TCP, and you want to pay attention to that, not just to the constants. Specifically, if you look at loss recovery, Ian pointed out earlier that the recovery period itself is actually different in TCP as compared to Quic. And this happens because Quic does not reuse sequence numbers. And as a result, you get past the, you do not have the notion of a QMAC point.
So Jenna, all of these things are excellent for the document.
I think they
use your pen, and
I believe these are now.
Let me defend that just very briefly. There is a in 06 we put in a bunch of text that actually does address some of these concerns. But yes, we can definitely keep doing.
07.
So I checked that
yes.
there's no 07 in the data tracker.
No, yeah, I actually.
Huh? Okay, so there's now, I guess.
The most recent version of it. It has some text, but
what I thought I was looking. Did it not get published?
No.
No, OSM didn't get published, but it'll get published now.
I think Mark is on it. He's faster with buttons than I am.
Yeah. Right.
Thank you, Martin.
Martin Thompson. The point here about advertising values, you do actually, as a client, then advertise values to the network. It's a consequence.
Oh, because transport parameters are not encrypted.
Transport parameters are not encrypted.
That's true.
So that's just something to consider.
You with your TLS add-on, I heard that there was some thinking in TLS about encrypting or at least obfuscating them, no? Okay. Don't wait for that. Okay.
Yeah, so yes, there are a number of ways in which you can do this, but they all have latency costs, and I don't think
we don't want
we're in a
those.
position to do that.
Okay.
We could build another mechanism for doing it later, but then that mechanism is maybe not particularly useful. So I'm just suggesting that we may want to think about the consequences of just throwing a whole bunch of things in there. So if this is truly valuable, then maybe the cost is not particularly high because the ACK delay is actually observable on the network anyway. So we could probably say, not a problem. But for the general class of things, as Eka pointed out, that we might want to add other things. We have to think carefully about what we're doing with these sorts of things.
Agreed. I think we should consider it on a case-by-case basis. I think in this case, the 25 milliseconds is actually a pretty reasonable default for the public internet, and I think most of the people who would be changing it would actually be cranking it down for data center environments. But yeah.
Yeah, cool. And so for the ACK delay, it might actually be useful to have a mechanism where you can actually change it later on as well, because you might see that your network conditions have changed somehow, and you want to adapt. I mean, it's most useful to have it right from the beginning, but it might be useful.
Yeah.
So we could, yeah.
Martin, we can't hear you.
That's what I'm saying.
Just to respond to that, if we need that, then we get encryption as well. So that would be fine. I was just thinking, if you want to do this in a data center, then you would do it in response to a chain, in response to observing a really low RTT, for instance.
Yeah, that might be kind of brittle, but yeah, maybe.
Hi, Sebastian.
Hey.
Maybe related to that, what about RTTs for sort of really short distances, local networks, cities? Can we go below 1 millisecond? Why is that chosen as a sort of a fixed unit of duration?
I mean, all these constants are, as I said, kind of based on like the Linux numbers, but like all the RTT measurements in Quic are designed to be microsecond accuracy. And when we did have timestamps, they were also microsecond accuracy, though now they're gone. So, but yeah, definitely, I think microseconds is the goal unit in all these circumstances.
Again, if we negotiate a transport parameter, it would be the maximum delay. And that still strictly makes TLP better, even if you adjust the value lower on the receiver side later.
Yeah, I mean, now we're really bike shedding, but the question, I mean, you only distinguishing microseconds and milliseconds if you're encoding out on the wire. So I guess the point is that if you're going to encode maximum ACK delay on the wire, you might want to move the units microseconds, given you only send it once anyway.
Okay. That is all I have. Thank you very much.
Oh, you have implementation tips.
Oh crap. I totally had one more slide. Yeah, implementation tips. So these are things that Google Quic has messed up at some point. So like, don't do these. Spurious retransmissions happen. You should really continue to track the data sent and lost packets for at least a little while after they are lost. You don't have to track it forever, but like at least some small period of time. Because, you know, weird twiddles and such do happen. You get one spurious act and one packet that like races ahead of others and declares 50 lost, and bad things happen. Never, ever retransmit an acknowledgement frame. Always send up-to-date ones. If you don't do that, like you'll be in a world of pain, and like loss recovery will work like absolute crap. Always send packets in packet number order, or you will either end up with spurious retransmissions or your implementation will be stupidly complex. Please always send them in packet number order. This also makes all the crypto people really happy because it gives them some like warm fuzzies that you are not reusing nonsense. So those are my tips, and bye.
That is the last slide. Thank you. Thank you, Ian. We're doing fine on time. I think it's 10:30. We've got one more presentation, and then we've got the discussion of the third implementation draft. So I think we're fine. And as I think was mentioned, we're hoping to see more implementation of this. We'll discuss that in the third implementation draft timeline, but then we'll have running code to get our data from, which is nice. And draft 7 is indeed now up, which is great. Yes,
sorry, one more question on the previous draft. The very first slide said that the draft does not recommend what to send. I had a brief comment on that. You were going to explain the philosophy of why that is. It might be still useful to suggest a particular retransmission strategy in the draft.
So I think the transport draft has some fairly like wishy-washy text about suggesting that if all things being equal, you should send retransmissions versus new data because the application is trying to make forward progress and it reduces the odds of like flow control blockage. I think there are some considerations in the draft about that as well, but I'd have to reread it. But the idea is just that there's not like normative language like you must retransmit or something. It does, I think, give you some suggestions. Like for tail loss probe, it says you should try to send new data versus like retransmissions. And the reason for that, of course, is that tail loss probes are very likely to be spurious in practice.
Yeah, makes sense.
So,
Ian covered most of what I was going to say there. Yeah, the point about new information versus old retransmissions of stuff is a question that will be informed by priorities, for instance.
Jana, I'll add that there's also the discussion we had earlier before when the draft was named early on about the possibility of later on incorporating partial reliability. And so this was really more about detection than about actually recovery. So the draft explicitly talks about detecting losses, not about actually retransmitting.
Maybe the draft can say that why it doesn't do that. So I'm making the same. So things you say at the microphone repeatedly should probably go in the draft.
No, so this is actually a fair question. I mean, I don't know if you want to mention partial reliability in the draft yet.
I mean, our charter mentions it, right? As something that we might extend, and so that you can say that certainly can inform the structure of the current document set, right?
I can take that.
And especially if we're talking about appendices that are explanatory that we can decide to take out later or not, that's pretty cheap for us to do. So,
fair enough.
This is your mic now.
Yes. So now let's move on to Jana's migration discussion. Sure.
I'm migrating.
Sorry.
You said Jana's migration.
Yes. To migratory.
No, I'm migrating.
And just before we start, anyone else need to sign the blue sheet? Hands up. Okay, I'll come around while Jana talks. Oh, actually, I'll come around after Jana talks. Go on. Jana?
Well, thank you for being here. I'm going to discuss connection migration as it is in the draft and sort of where we want to go with this in changing the text in the draft and sort of moving forward with mechanisms that are more resilient, that are stronger and more useful. I'm not trying to nail down all the details in this discussion. This is really a higher level discussion. This is meant to get feedback from the community about direction and about principles. So to the extent that I've been able to, I've tried to pull some principles out. If you think there are others that you think should be considered, or if you think these principles are wrong, this would be a good time to talk about them because we expect to continue working on this, and this is an initial sort of sense of the direction that we are heading in. Next slide. So the behavior that's specified in the current draft is as follows. When a client, I'll say client instead of peer because really we are talking about the client server case, and even though the slides here will say peer, what I'm going to limit the conversation to for now at least is when the client is moving and the server is stationary. When a client moves from one address to another, it basically sends data over the new address. The server observes a packet arrive from a new address on the same connection, and it sends subsequent packets to this new address. This is effectively what I'll call latching behavior, where the server latches to a new peer address. The server limits the data that it sends to this new address until it can validate that the address is in fact owned by the client. and it uses a ping pong message it sends a ping and receives a response back from a pong frame back from the client to validate this new address. This is the basic mechanism that we have right now. This, of course, assumes that there's only one address available at any given time in the client. This works well for a couple of models. It works well basically when you've lost connectivity on one network and you get connectivity, and this is the make after break situation. It also works well for inadvertent migrations, or it works well for NAT rebinding, where the old address is basically gone completely. The problem with this approach, of course, is that it allows for it keeps you from being able to do proactive migration when you have multiple addresses available, multiple networks available at the client. And it also is actually, there's all you need is one spoofed address, one spoof packet to go from the client to the server, and the server latches onto it immediately and then tries to validate it. It doesn't try to verify the address first before starting to use it. So this model obviously has issues, and I'm going to try and propose some ways forward. Next slide. So in practice, multiple addresses are often available, and I'm going to use this as a way to think about the solutions that we want to build. Specifically, let's just go with cell and Wi-Fi because that's the most common use case at the moment, and that's the most common case that we expect to get used in the short term at least. And in some cases, definitely in this case, clients tend to have a preference. They tend to have a local policy that says you prefer Wi-Fi over cell. This is common of all the platforms I know of, but in general, it's possible and it's likely that the client will have a preference for a particular network even when two are available. So in that world, when migration happens with multiple addresses in this world, I'll draw out two scenarios. And these are, again, example scenarios, but these capture a family of cases. The first one is when a mobile client, for instance, connects to Wi-Fi. This is when the mobile client is already on using cellular data and has migrated into Wi-Fi. So this is you walking into your house or walking into your office from outside, for instance, or walking into a place where you have Wi-Fi access and the mobile client suddenly has Wi-Fi available. What you want to do is to migrate existing connections that are running over cell over to Wi-Fi because there's a preference for Wi-Fi. But you only want to do this if Wi-Fi is actually, you can actually reach the peer via Wi-Fi. For instance, if you have Wi-Fi connectivity, but if there's UDP blockage, or God forbid, Quic blockage that actually happens on the Wi-Fi network, then you won't be able to speak to the peer over this, and you don't want to discontinue using cellular under these conditions. So Wi-Fi is a preference, but you want to continue using cell if Wi-Fi is in fact not usable for you for this connection. The second use case is when Wi-Fi quality degrades. So the second scenario, I call it. This is the infamous parking lot problem. This is when you have a phone and you're walking out from, again, your office or your home, and you're walking into the parking lot and you are trying to do some work on the phone, or you're trying to look up directions, and you're walking out into the parking lot, which means Wi-Fi quality is degrading, but your phone will not let go of Wi-Fi. And this is platform decisions that are generally universal. Platforms, operating systems do not. They make conservative decisions about when to drop Wi-Fi, because again, like I said, Wi-Fi is a preferred network, which means you don't want to drop Wi-Fi unless it's really, really, really gone. So they hold on to Wi-Fi for dear life, where your cell signal could be strong and powerful and absolutely wonderful, but you have no connectivity effectively because Wi-Fi is really, really weak. And this often lasts for a long period of time. In this condition, under these conditions, you want to be able to migrate existing connections from Wi-Fi to cell. Again, this is given that the client and the application have privileges to do so. But because of the preference for Wi-Fi, you want to be able to migrate back to it if Wi-Fi in fact gets better. So this is if you were using Wi-Fi and you turn on the microwave and Wi-Fi blacks out for like 2 seconds, you want to come back to Wi-Fi when that network is back. So these are the two scenarios. And next slide. they expose this need that you want to be able to probe in addition to simply send data. Currently, as I said, all we have is a mechanism to latch onto a new network, latch onto a new path, latch onto a new address, and send all data over that path. But really what we would like here is the ability to send a probe in addition to sending data. So you're sending data over a path that you know and you love, and you want to try a new path for whatever reason, and you send a probe packet, and you then respond to it. So that's sort of one of the principles here, is that we want to be able to make probing and latching separable events. And that's something I'm going to be working with on the next one. What this means is that a peer, when it receives, so this is not only when for an endpoint to send a probe packet in addition to data packets, but when a peer, in this case, as I said, with client migration, the server receives a probe packet, it is not going to latch onto that new address. You want it to simply respond to it and continue sending to the old address. Next slide.
Tatardi, a quick question before
Yes.
you leave probing. In a lot of the cases in devices which combine cellular and Wi-Fi interfaces, when you have a Wi-Fi interface, the data channel is not available on the cellular interface for an existing connection. And so in those cases, how would you craft a probe such that it causes the data channel to actually come up?
Oh, you mean the cellular network is not in fact up?
Well,
meaning
so
it's
the
not usable.
cellular network, you have signal and you're attached, but there's no data channel, right? So you're.
I understand. So
yeah, and so you may have a situation here where in order to cause the data channel to come up, you may be reaching much further into the OS stack than you think you are. The transport itself may not be able to do that. Depends
Yes.
on what the knobs are in like certainly in Android 6 and earlier, you couldn't do that at all.
I completely agree with this. So this is why I sort of I alluded to it, but I didn't get into it, which is why I said that I'm assuming that the client app has the right privileges. What I meant is that the client app has to be willing to pull up the cellular network when it needs to do it.
Okay. So I don't think we should rat hole in it, but
Yeah.
maybe you and I should talk offline about how this works in Android in a little bit more detail.
Before you leave the mic, do you think this is something that is a protocol spec issue or an implementation issue? Because I think of it as a protocol spec issue. Sorry, an implementation issue.
I think it's definitely an implementation issue, but I think what we need to be cautious about here is when we say that we want to probe an interface, the existence of the radio and the fact that radio has a connection to the network does not by itself indicate that there's a path.
Absolutely.
Right? And so when we talk about probing in order to create, with the probing by itself, in some cases, will not instantiate this alternative network, even if you have these other conditions. And so what worries me about that is if you actually did want to do make before break, you actually need a facility from the OS that says, hey, I need a data channel for this, which may mean you may actually have to change some OS level fob that currently says, hey, I'm going to prefer Wi-Fi over cellular, because I'm data conserving in order to make these probes actually work in practice.
Okay, thank you. I think that might actually warrant some text when we're writing this up. But thank you.
Tommy Pauly, Apple. Just to speak from kind of like our implementation side, not on the Android side. Yeah, I think this would work just fine. I think one of the benefits here of Quic being often implemented in user space is that there's a little bit more ability to play with knobs and poke things like getting the radio up. That has maybe been traditionally harder within a TCP stack within the kernel to interact with the cellular interface that way. Oftentimes what we will do when we're doing path evaluation is you can have your path that's in a not complete, like available but not ready state. And so you would see that, and if then Quic decided it wanted to probe, it would have to essentially kick that radio, wait for that to come up, and then be able to send the probe. So maybe explaining that there is this transitory state that may be involved and that you may want to dial a radio, because that also applies for things like if we want to get into like VPNs and being able to be mobile across virtual interfaces, sometimes those also need to get kicked. So yeah.
Spencer Dawkins, I'm not quite sure what hat I'm wearing, but so let me say it. You could tell me which one I should have been wearing. I'm asking a question that I think is about 90% rotation from Ted's question, which is how stable do you think the ordering of preferences would be? Is that something that would be like a natural law, or if it's not a natural law, are you thinking, is there anything we need to say about the way that somebody somewhere can express those preferences? And you don't have to rat hole now. I just needed to ask.
My sense is that also falls in the realm of implementation. This is implementation specific. What I think we may want to do here is make sure that we talk about interfaces as having, or net addresses as having preferences, but not actually talking about how those preferences may change.
Praveen, yeah, this does seem like an implementation issue. I think what you're trying to say here is that when additional interfaces are available, like that there is layer 3 connectivity, is when you probe, versus saying that you explicitly require that Quic be able to kick up the interface. So it could be reactive behavior versus proactive, depending on the system policy, versus Quic dictating when it brings up and tears down interface. Because you could, for example, kick the network, you could bring the interface up and assume that you've sent the probe and everything is good. But later, when you kick the interface again, the addressing information may have changed. So just the fact that you've probed may not survive.
So you make an interesting point, and I did think about that. So the what you're talking about is whether there should be, as you mentioned, we should proactively probe and keep paths around for fast switch over to, or whether we should kick a path and send a probe only when we are actually experiencing degradation or failure or whatever have you. The SCTP model for this was very much negotiate the paths and keep them, and sort of switch to it when you have it, right? But I'm deliberately not getting into that, but I think that may warrant discussion as we write this text out.
Eric Klein, Android. I'm not quite sure what Ted's point was. I do think this is an implementation issue, but I also think we should not really necessarily speak in terms of interfaces, but addresses, because everything here should work identically for rotating the connection across multiple IPv6 privacy addresses on the same interface.
Point taken. I completely agree. In fact, I'll just take this moment with this moment to note that I may have used network address interfaces sort of interchangeably in this presentation because of the flow of text in my head. But when we actually write this up, I agree with you that we should use addresses.
Yeah, the relationship between addresses and interfaces and paths is something that operating systems, mobile operating systems in particular, like have varying notions of.
Understood.
Tommy Pauly, Apple. I just want to reiterate, and I think you agree with this, but just say that like the document should be fairly agnostic to what the system policy is. It should be describe the mechanisms, but both in terms of what preferences we have, that's definitely going to be determined by the system other properties, but also the aggressiveness of switching over. I mean, for example, when we have preferences right now for doing MPTCP, we've actually exposed in kind of higher level APIs, does the application have a preference to do essentially a failover mode, or does it want to have like interactive mode in which you kind of keep things up? So both should be possible here. This relates to some of the work that we're doing in TAPS about how do you specify application preference for your resilience on this type of link. So being compatible with that would be good.
That's actually very useful feedback. Thank you. All right, moving along. This is the moving on from the latching and the latching being separable from data. In this example, at least, we were talking about the mobile client being able to decide when to use Wi-Fi, when to use cell. This certainly tends to be the case for Wi-Fi and cell, where the client is very clearly in charge of deciding whether it's okay to use cell for this particular request, for this particular stream, for this particular connection or not. And even if cellular data is available, the client may not want to use it for this particular transaction or for this particular stream. And that's something that you want the client to be able to decide. This is a policy decision, as Tommy was pointing out, based on various preferences. The policy decision can play out in a number of ways, but you want this to be a client local decision. On the flip side, the sender is usually the one that has the best idea of what network quality is to the receiver. And in this case, if you think about the server as being the sender and the client as being the receiver, then the server has the best picture of what network quality is. So there's a bit of a tension here. But I think that my sense is that what we really want is to ensure that the policy decision is enforced. And when we are able to, we allow for the performance argument to happen. So the principle that came out, which is the principle that came out of this for me, was that we want interface. I'll use interface here again instead of address, but address use is a local policy decision at the client. And when it's possible, we want the mechanism to support the server's ability to choose. So this could be useful in a case where the client says, I don't care which interface or which network is used. They're both equally good to me, and wants to tell the server that you can use them at any which point you want. That's something that we may want to offer as a freedom in the mechanisms that we build. Next slide. So here's a straw man with sort of with bearing in mind these two principles and the discussion that that we've had in the slides so far. The same two scenarios that I used at the beginning, I'll walk through them. I'll walk through a particular way of doing them with these principles in mind. And the details obviously can change as we go through it, but this is a straw man. When the mobile client connects to Wi-Fi, which is when your mobile client is coming from cellular to Wi-Fi, it finds Wi-Fi as a network that's available, sends a probe packet over it, and continues sending data over the cellular network. The server receives this probe and sends an ACK of it to the source address of the probe. Basically, what we want is for the server to respond to the probe over the cellular network. Over the Wi-Fi network, but we want the server to keep sending data over the cellular network. When the client receives confirmation that this path in fact works, the client switches to sending data over the Wi-Fi network, and the server simply responds to that data by latching at this point. Did you have a question on this, Martin? Or do you want me to go through the rest of it?
So, Martin Thompson, I wanted to get through the example. To Tommy's point earlier, I think this is just one of the many approaches you might take to doing this, right? So, the example that we have in the sort of what's documented right now in the draft is a potential policy that someone could apply here, which is, oh, Wi-Fi is available, drop the cellular, move straight to the Wi-Fi. It's abrupt. It breaks things. It's going to take some time before things get working. This is a reasonable policy also. If you're actually concerned about throughput during this process, this doesn't allow you necessarily to open the C-wind on the new path particularly well. And so you might leave the cellular.
Can you repeat that sentence?
So this particular design, assuming that you reset your congestion controller for the new network and new path, won't allow you to have the same C-wind that you previously had. So you won't necessarily get the same sort of throughput that you would have had on the cellular connection. So it is possible that someone keeps the cellular connection open for a little longer just so that the Wi-Fi C-wind can come open. I think all of these things are possible. So just sort of putting that out there.
Hi, John. What's your threat model for this design?
My threat model for this design. I do not, well, I was spoofing shouldn't cause the, so there are two things in there. One, you don't want the server to start sending to an arbitrary IP address.
Yes.
Because some client spoofs somebody else's IP address. And now that client, that could be the client or that could be a third-party attacker. So if a third-party attacker sends an arbitrary packet with the spoofed IP, it shouldn't go. The server shouldn't start latching and sending somewhere else. Similarly, the client wants to drown somebody else in data. You don't want a DOS attack possible, or an amplification attack possible with this mechanism.
Okay, so I'm not following, I guess, step 4.
Which is the server receives data packet over Wi-Fi and latches to
Okay,
Wi-Fi.
so the idea is supposed to be, I believe, that, so your claim is the client's not going to cut over to Wi-Fi until he's received the acknowledgement of the probe, correct? And so the transmission of data over Wi-Fi is an implicit round-trip demonstration.
Yeah, I think I see where you're going.
Well, I guess.
Get there.
Okay, well then maybe you've thought of this problem completely. Yes, please.
So the probe here is an explicit return routability check with entropy in it. So the server is going to send a probe over Wi-Fi, over the new address of the Wi-Fi, and so the server's going to probe too.
So this is actually. No, server doesn't. That's what I. No, the server doesn't in this case. So
you haven't put that in the example, and I think that's important to add. Yeah.
So this is yes. I think what you're pointing out is that the server needs to validate that the client is in fact legit.
Well,
right?
I mean, yes. I guess I'm trying to understand what it is. What characteristics? Forgetting at the mechanism.
Yes.
What is it you believe that an attacker with given capability should be able to do to this?
Yeah.
And in particular, like, if I have momentary access to the network, can I divert you on another network, thus causing that connection to be torn down, for instance?
Yes.
And so, well, that's one thing you might want to do. But I mean, so it's like this. So the design you have here, right? If I have essentially access to, if I can basically get one packet out of the well, this design does that.
Hang on. Hey, don't have a conversation like this. I can't even hear you. Others certainly can't.
Maybe you should just. That's why I'm asking about the threat model, not about the design, right?
So that's a valid point. I think I missed saying here that the server needs to validate the client as well, and that's something that we want to do. Now, to the point of the probing packet, this is going to end up being actually a different type of packet. It's not going to be your simple ping pong frame, and I'll talk about that in a moment. But yeah, at the moment, let's just talk about this as a ping frame with random bytes in it. And that's fine, but we need some more constraints on it.
Ted, I got up when Martin was talking earlier because he was trying to point out to you that the current make after break model may be a policy of the end system as one of the potential policies. But I would like to point out that one of the things the first mechanism was designed to handle was NAT rebinding.
Yes.
Right, and so that's it's not really a policy of the end station, but that will continue to happen in the presence of this other mechanism. And so a really basic question we have is whether we're going to try and make the mechanisms for confirming when you've seen a NAT rebinding style response and one of these other migration with multiple addresses, the same response or not. I think the simplest thing is to say no, they're not. But the most elegant thing is to say, yes, they are. So I think we probably need some discussion on where we fall on that.
That's a good point.
Jörg, since we have been speaking before about this retransmission draft, do you have notions that you should be, maybe since you're going to see a new different RTT, that you might be more conservative on your aggressiveness of retransmissions?
Wait, can you? I didn't follow the question.
I mean, we had a reasonably aggressive schedule for retransmitting packets. If you are switching interfaces, you're going to see potentially quite different RTTs, which may make you retransmit stuff even. But since this is a local policy decision, I as a sender know that I'm going to change interfaces where I may experience different RTTs. Which means, since I know this, I'm trying something new here. Maybe I should be reconsidering my retransmission schedule if I'm trying to figure out whether something got lost or not.
Yes, I mean the short answer. I talk about this in the next slide. This basically, no, I don't get into the details of how to fix it, but absolutely, this is going to interact with loss recovery in a couple of interesting ways, and we're going to have to walk through that.
Praveen, so regarding the threat model, so you said the server needs to validate the address, right? So I'm wondering if we really need a probe or whether the client could just send its set of source addresses that it could use potentially as in the encrypted payload.
So that's a.
I'm asking, like, is there any value to the probe other than validating the?
Yes, there is, and the value is basically that the client doesn't actually know what its addresses are because its packet goes through a NAT that translates the IP and the port numbers to something else. Okay. So you need in-band, not in-band. You need explicit signaling.
Tommy Pauly, Apple. Yeah, I agree with that point. On that point. So when we're looking at the threat model and other things, I wanted to bring up a suggestion of another prior art to look at in this area for an encrypted protocol that goes over UDP that is mobile between interfaces that we've already analyzed, which is Mobike for IKE v2, so mobile IKE. And so it can essentially do this for an IKE session. And so that is dealing with encrypted packets. There's explicit handling of NAT rebinding in this. So when we're looking at kind of the security analysis, let's just look at the same considerations that were done in those documents, and they may be really good to just bring over here.
That's a great suggestion. Thank you.
Xavier Marjou. I was thinking about possible consequences for other applications on the same device. Do you see the Quic application as being able to activate an interface, or only as a, I would say, a slave application that would react accordingly, for example, if the two interfaces are already activated?
So this again sounds like an implementation question to me about exactly how these mechanisms are in fact used. The goal here is to identify principles and sort of higher order questions that we can use to design mechanisms that applications can then use. But I think correct me if I'm wrong, but it sounds to me like what you're asking is a very specific use case question of implementations, how they might actually use multiple interfaces.
Yes, but it was, do you think that Quic will embed some function in order to activate or not an interface?
That is definitely an implementation and API question. I think that is probably not something that we're going to be able to speak to in direct terms here in this document anyways.
So Martin Thompson, I got in line so that you would get to the next slide. So I'm going to wait here until you move to the next slide.
I haven't finished this slide yet.
You haven't finished this slide yet?
No.
Is there any new information we're going to get from that discussion?
Well, I'd like to finish the slide and find out if there's discussion. Okay. I'm sorry. Let me. Do you want me to finish the slide, or do you want to
wait here until you finish the slide? Yeah.
Okay. Let me try to do that. So the first half, I walked over what happens when a mobile client connects to Wi-Fi from cellular. If you remember, I also mentioned the parking lot problem, where a user is walking away from Wi-Fi into cellular, and the Wi-Fi network is degrading. And what you want to do here is what in the case that the client app is able to aggressively move data over to cell, but keep sending probes over Wi-Fi. When Wi-Fi comes back up, switch the data back to Wi-Fi, because Wi-Fi is again the preferred network. This is exactly SCTP's failover model, by the way. But that's basically what this covers. Next slide.
Okay, but I'm going to note it's under duress. This is explicit head of line blocking, which is just trolling us.
So this question is not exactly tied to the specific slide, but is probably worth saying in general. So where does connection migration fit into the role, into the work of the working group? Like, is this a focus area? Is it in scope for version 1? Do we need to talk about it now at all?
I believe it's in scope for version 1, but I don't want to be the one to say this.
Well, certainly we have to survive a NAT rebinding.
Yes.
Beyond that, I think that's the discussion we need to have. Yeah.
Can I down level real quick and then up level?
Well, before we conclude this discussion, let's make sure we up level.
Yeah. I'm going to come back to the mic then.
Wow. Okay.
Rick Taylor, I think this leveling point, I missed half the conversation there, but I think we're disappearing quite deep into the weeds here. I think the role of Quic is to understand that it may have multiple addresses and bearers may come and go, but how that happens is not Quic's responsibility. Quic should be able to cope with this occurring.
Yes.
And how that happens is totally beyond scope.
Yes.
Just the mechanism to react to that, great.
So just to ground that discussion a little bit, this is the part of our charter that discusses migration. So make that bigger. So, and I noticed the word extend.
So, did you want to go to that discussion, or do you want me to finish?
No,
this
just
slide?
wanted to get that so that it doesn't cause more confusion. Let's go back to your presentation.
Can we leave that up
Brian is
because that's my
pointing.
question?
No, but we don't.
Sorry?
Can we go back to the charter real quick?
Sure.
So I wanted to point out that we're really creeping into designing a multi-path transport protocol here. And I want to make sure we don't do that accidentally, because so all of the policies that I've seen here, like there's only one little tiny tweak that you have to make from, okay, now I have 2 up, or I have 3 up, or I have n things up because I'm using them for probing, and it's a line of code to send data over that.
It's not a tiny thing. It's not one line of code. The big difference here, and this is perhaps something I should.
Okay, so I don't understand why it isn't so.
So let me point out the big difference, unless Lars wants to jump in to say something.
No, I actually want to, echo Brian's point in the sense that, some of the things you need to do to handle this case are also things you need to do for multipath. And
Yes.
it would be awful if the things we did for multipath were completely different from what
So-
we
Yes,
did here.
Lars said what I'm trying to say much better. Thank
So
you,
let
Lars.
me articulate this perhaps in a slightly different way. Multipath uses multiple addresses simultaneously for sending data, for sending everything. What that means is that the center has to maintain multiple congestion control contexts, multiple loss recovery contexts, multiple everything. Congestion, when you have multipath, connection migration is always going to be a special case of it. The question here is, how do you get connection migration without having to implement the entire giant multipath thing? And it's entirely possible. You have to be able to do, so this is again, for people who are familiar with how SCTP did things, there was a failover thing in SCTP, and then there was the multipath thing in SCTP, and this is very much that divide. The failover is incredibly useful. I'm actually going to argue for having this in V1 because I believe that we want to have this as a fundamental property of the protocol that we use. But
okay, my name is Yoshi Nishida from G Global Research. Maybe this is similar to the previous
Fix the microphone first and then start speaking.
Sorry. Sorry. So this may be similar to the previous comment, but no, I would like to. So this is very similar to what SCTP is doing for address management. So I'd like to understand what's the difference between the SCTP address management and Quic. And then if there is a difference, I would like to understand why it's different. And if you could clarify this point, that would be great.
so the one difference is that SCTP has exactly, I can't remember who asked this question, but somebody asked, Praveen asked this question of if a client can actually expose all of its addresses to the other side, and if the other side uses it whenever it wants. That's the SCTP model. The Quic model is you have to send a packet over an address, over an interface, over a network for the other side to be able to use it.
What happens if the other side is behind a firewall?
I'm sorry? Can you answer that again?
Oh, what's happened if the other side is behind a firewall? How you send a packet, probe packet to the other end?
Right, and your probe packet may not get through. And the packet doesn't get through, you don't migrate to that path. So bear in mind that connection migration only kicks in when you already have a connection that's running. So this is not applicable during handshake. I actually had a bullet, I removed it because I didn't want to proactively say this and then get everybody at the mic. But yes, we don't want to support this during handshake. This is going to be after the handshake is completed, which means that you have a running connection.
Is that the only difference? I think it would be great if you clarify this point in the draft. That's my feeling.
I'm waiting for our chairs to come to some sort of conclusion here.
Sorry,
One of the variance.
I think Martin wants to ask us something.
Go ahead.
It seemed like you wanted to say something before. I wanted to.
No,
We're actually talking on topic and not just, you know.
Oh, okay. So,
Yeah, I'll go to the gate tickets. Okay.
whoever it was that caused us to up level, that's great. Given that we're trying to be aggressive about these sorts of things, I'm inclined not to do this. Despite the fact that I actually think that Jana's design here is fundamentally correct and it's something that would possibly work really well and have some great advantages. The probe packet and that notion actually kind of exists already in the current design. It's just not very good.
It's kind of.
And kind of may just be enough for us right now.
Oh, are you talking about not doing this being what?
Yeah,
the
Not doing not defining any special mechanisms to allow for concurrent use of multiple paths and explicit probing, but rely on the existing mechanisms that we have.
So let me rephrase that and you tell me if I got you right. Are you saying that we should not support make before break?
Not explicitly, yes.
That means we won't support make before break.
Well, so we could, in fact, support make before break with the design as documented. It is just suboptimal.
No, that's a make. I mean, yes, it's a make after break design.
No.
You don't use the old address.
So if you actually sit down and understand the design and go through in detail, you can send a probe on a separate path, and sending an additional packet on the original path will cause the other path to latch, but only momentarily. So you'll get packets traversing both paths for a period of time. It's not good. It's not as good as this, but it means that we don't get into all of the details of this and spend time on that, and we can spend our time maybe productively doing, say, header compression, for instance.
Yeah.
Which
So the thing we talked about is actually, I think when the charter text was written, there was an assumption that the working group on the side would have already spent some time talking about multipath and multi-homing. But we haven't had that time. And so the idea was we would have thought about this already, and we would break off the stuff that is understood well enough and stick it here. But I don't think we have done that. And I think you're getting to the point that do we want to do this before V1? Or what's the minimal thing we can do before V1 that lets us do something that isn't going to be terrible later on?
So I'd like to speak to that if I can.
Yeah, please do.
I don't think that the mechanism that's specified in the draft it's not suboptimal. I think it's incomplete. That's your problem. If you try to implement it, you're going to find that it's incomplete. And I see Tommy nodding his head in the back there.
It probably is. It probably is.
It's incomplete. Yeah. We need some of these things to actually make that work. I understand your point that you can, yes, the latching point I'll grant, but you need to probe the alternate path. You need to actually be able to explicitly send a probe packet and you need to be able to deal with the consequences of sending a packet there and coming back, because you don't want the congestion controller to get reset twice.
That's all in the draft. That is in
no,
the draft.
I know. So you have to list out how the packet number for the probe packet is going to be part of your same sequence space.
Sure.
These are the details that we are going to still have to work out. And once you work out the details, this is what you get.
So the consequence of that is that we spend a lot of time on precisely that. And if we don't explicitly commit to doing make before break, then we don't have to do that. And that's my point.
So that would basically mean that we would support NAT binding, but no migration effectively.
Migration, but only in the break before make sense.
Which is not, in practice, it's not going to get used.
Right. But
I can tell you this.
If I can just interject here, I think we need to have an explicit discussion about what's in version 1, what are the requirements for version 1, The charter says that migration as well as multipath are extensions. It says extend.
Does it say that for migration as well?
Well, it's
said that for
it's a little
multipath, I know
fuzzy.
that. It's fuzzy on migration, I agree.
Right.
It's fuzzy, so we should resolve it some.
We should resolve that, and then we need to find out how this affects our invariance. I think those are the two things that are on the critical path.
Right. So that was why I was suggesting.
And you were
shelving it,
suggesting
but-
a way to
right,
navigate.
and we have some migration in there. It's just not. I totally agree with Jana. It's not good enough. But
Hi. So, well, I see that protocol as really different from load sharing, and it is something that is already been deployed, especially for VPN. So, I think using this alternate path is already something we have experience in, and it's something doable. And I kind of support this effort, having this alternate. That we need the probing or not can be solved.
Tommy Pauly, Apple. So Martin, I disagree about kind of the approach on this. So absolutely, the full multipath, because this is not full multipath, there's a lot more there. I get that being out of V1. I think anyone who is interested in multipath should review this to make sure it is not conflicting. I believe it is not. This is the control part of multipath, but nothing more. If we can do a kludgy version of handing over between interfaces today, I don't believe we're going to implement it. I will probably on the platforms will make sure it's disabled, and then we'll essentially be shipping a protocol that has an ability that's kind of a dead thing that will need to get revised and updated. This, I don't think, adds that much complexity. I think it is, again, well understood in other protocols. It's a common model. And if we're going to put anything in, let's just do this. Essentially, the existing model is there. Like, the only argument for it right now, it seems to be, is just inertia, that it was already written. And had it been written this way originally, it wouldn't be a problem. So what is actually beneficial other than just not wanting to take the new text for this? Okay.
So I'm going to cut the queue at this point, because we are a little time constrained. And again, just to reiterate, from my perspective at least, I'm listening for why we need to do this in version 1 for the use cases we've talked about, or why it's something that needs to be in the invariance. That's what I'm still listening here. Not generally, is this good or not?
Can I quickly address the invariance question?
Sure.
I don't think this changes the invariance.
Okay, so this is something that we could introduce in V2 safely?
Yes.
Okay, and if someone disagrees with that, I'd like to hear about it.
yeah. So Martin Thompson, if we're going to spend this long arguing about whether we do it, we should probably just argue about how to do it correctly. My point was that we can perhaps save some effort and time. And if it seems like people are interested in the feature, to the extent that we're going to spend more time fending off the requests for the feature than we are in actually implementing the feature, then I'm perfectly okay with implementing the feature. I was just raising the possibility.
Okay.
Mia Kulovin. So I think this is an important use case which will make deployment much easier and more beneficial. And the other point is, this is like halfway going to multipass, right? So if we add this right now in the first version, it will be much easier to design multipass later instead of redesigning a lot of things again. So if you just think about how would you design Quic with multipass in your head to add it later, this would be the right direction to go. And one completely different point, because there was a comment about middle boxes and nets. So this is something else we might want to add, like requesting the other side to send you a probe, maybe. Telling the other side, please send me a probe to this IP address. Not sure, just proposal.
Yeah, Brian Ford, EPFL. Just to add to the migration versus multipath, I'm concerned. I feel like a lot of both mechanism stuff and policy stuff feels like it's getting kind of lumped together here. Or at least I don't see the distinction being very clear either here or in the current draft document. I feel like the mechanism needed for both migration and multipath should be practically the same. Packet for packet formats, methods of being able to probe, figure out if you have and can potentially use particular addresses versus the policy, and so the mechanism should be identical across migration and multipath, whereas the main difference is in policy. Right? A migration is a policy that, is a type of multipath policy where I just decide to use one path at a time, and I have certain ways of deciding when another path is more attractive and switch over to that completely, right? So I also see, and I think you're right that, a migration type policy can probably be done more simply than a full-blown multipath policy, and that's a good intermediate step to have. But then there's also going to be like, I don't want any policy at all, like somebody else mentioned, kind of just have the dead thing when we don't want that at all. So I guess, kind of to summarize my point, I think the most important thing is is from the very start be able to distinguish and express the distinction between these levels of mechanism and policy very clearly from the start. I think it's very important for all the necessary mechanisms for migration and multipath together to be in 1.0, hopefully, or kind of at least not impeded at all. But maybe both the migration and the multipath policy stuff really should be, separated, cleanly separated out extension or something like that. That's just kind of how I see it.
So let me address that very, very quickly. What you said there, that connection migration is simply a policy. That is the view that you can take when you have multipath. So when you have multipath, you can say that connection migration is one particular instance or one particular special case of multipath. What I'm trying to do here is to not go there. Basically, how can we make connection migration a special case of single path is what I'm trying to do. Specifically, what I mean is, what exceptions can you make to allow for sending one packet on the side?
Okay,
rather than
I see your desire, but my big concern with that line of thinking is that you're going to get almost all, you're going to get a large fraction of the complexity of multipath. And I'm already seeing that, like, in the draft, kind of the migration part of the draft is already huge. There's a lot of text there. And, as you say, it's still very incomplete, even just to get migration. Especially the policy stuff, that's going to be, a huge amount of complexity in terms of specification, if not implementation already. I'm not sure how far, along the way to multipath that is or isn't, but it's already a lot of complexity.
So there's an interesting distinction that you just made, which is, complexity in specification versus complexity in implementation. To some degree, we should try to reduce complexity in specification, but we definitely do not want complexity in implementation. So when you're doing multipath, like I said, you will want to instantiate multiple congestion controllers, multiple loss recovery contexts, and so on, and you do not need that for this. So the question is, what exceptions can we make and can we live with? They're not going to be perfect, but can we do something that's a basic extension? And like I said, if you don't want to use a different loss recovery context, what can you do? Simply. It might be suboptimal, but can we live with that is the question that I'm trying to answer.
Yeah. Okay.
Andrei Popov, Microsoft. So observing that the UDP-based transport, for example, is likely to work on some interfaces and not on others, would it be more useful to define migration such that it works across transports? So it's not then Quic specific, but can, for example, migrate from Quic to TCP, right?
Not,
and if
not
that
part
is
of
the
our
case,
charter.
would it be better to define it
Not
outside?
part of our charter.
Ian Sweat, Google. After hearing Martin's comments and reading the section fairly recently, I think the current section is, it probably was intended to potentially accommodate some of the things
yes.
here. Okay. Anyway,
No,
I guess my point is, I think we could take on a small amount of work to make some minor modifications to the current text, and make this possible without like, overburdening like implementers. And that would be totally sufficient. And I would support doing that now rather than later because, I think this is like super useful. So, I mean, there are other alternatives, like peers can unilaterally negotiate that this like mechanism or this policy is like available, but it's a bit of a hassle.
I'll
And I've asked Martin to the mic because I want the editors to understand what our path forward is here before we leave the meeting. So, you have a question or?
Yeah. So Martin Thompson, as I said, I'm not opposed to doing something better here because obviously what is there is not enough to address these sorts of use cases really well, even if maybe it could be hacked together. But I think I'd like to see more of a fully worked proposal for that because the information you've got in your slides is not enough information for me to decide whether this is right or not. And I'm particularly concerned about the use of new connection IDs and the packet number gaps and those sorts of things in this context because that probe is going to want to have a different connection ID and a different set of, effectively a separate packet number space. And that, right, but the problem there is that if you flip-flop between them, in our current design, we have packet number gaps every time you flip-flop. And I don't think that's going to work. And so those details and interactions with loss recovery, the consequences of the fact that you have different path delays and the loss recovery treatment of these things. So you're going to be sending what is logically packet number X here, X plus 1 and X plus 2. And if X plus 1 is reordered with respect to X plus 2, which is highly likely, the other side is going to treat it as lost immediately upon receipt of X plus 2. So all of those things I would like to understand in a lot more detail before we do this. And that is why I'm concerned about the expenditure of effort.
Right.
So that's...
Hang on a second. So we're running rapidly out of time.
Yes.
I booked the Butterworth breakout room from 12:30 to 13:30 today in case people that want to discuss this more need space. It seats 12 people. So
12 to 12:30, you said?
Yes, 12:30 to 13:30.
Yeah, don't plan on eating people.
So if
it's not going to work for me.
So that's one thing. So I'm just reserved that if it works for somebody, that would be good. If it doesn't, then I'll unreserve it. But I think we need more time on this than we have in this session.
Yes.
So if that,
I think
if that doesn't work,
I think what I'd like to suggest here is that Jana and some people who are interested in actually solving the problem and have experience with it, actually go off and produce a proposal. And until we see that proposal, we don't discuss it anymore, like we've done with some of these other things.
I think that's completely fair.
Shelve
so
it,
the
have a
intent
design
of,
team.
Agreed. So that was the intent of kicking something like that off. Specifically, there are people who have proposed multi-path designs on the list that we have basically not discussed because we didn't feel that we have the time for it. But at least in some people's minds, this is very clear. And I want to invite, I know at least 2 groups that have done this already. I want to make sure that they're in. So let's find out, Jana, do you want to be on point to get a group together to discuss this?
I'd be happy to do that.
So if you have an interest and a background in this, send an email to Jana and explain what your interest and background is. And if Jana believes you would be a useful addition to the group, he will reply. And otherwise, I guess he'll reply too. But
oh my God, you're making me seem okay.
So I mean, we can't have a discussion with like 50 people, right?
No, so that's I mean,
why.
so
I think we're looking specifically for people who have experience with this type of mechanism in other protocols, specifically multipath TCP or SATP, who have thought about or even done a design for this for Quic. But we're not interested in people that just want to listen because we don't have space for that.
So I'm happy to do that. I'll just say that the text that's in the draft right now is not accidentally trying to do this. It's actually deliberately trying to do this because that's the model of connection migration that actually makes sense and works. But I agree that there's potential complexity that we need to think about.
Okay, and we'll figure out after we've talked whether this is a formal design team or just a discussion group or something.
That's the question I was going to ask you offline, but okay.
Yeah, so I don't think we know either yet, but it seems like we need a smaller group that goes off in a corner and does something for a while.
And again, I'd encourage, and it sounds like you're doing this, but I'd encourage everyone involved to keep the scope we're thinking about in mind, rather than designing it for all time. Do you want to finish your?
I don't know if there's much point. Can you go on to the next slide? Yeah, this is just talking about sort of issues that fall out of working on this, which doesn't make sense to discuss anymore, I think.
Okay, right.
The question basically, we need something for V1, right? And it would be awfully nice if that's something later on slotted nicely in with the full multipath.
So
I think that's the challenge, right? What piece can we break off that is, not 90% of the full multipath, because then we might as well do everything and we don't have time for that. But it's a small subset, but slots into.
I'll push back against that way of thinking, because I do not want to think about this as a special case of multipath. I think when you start doing that, you design
I don't
and cut
either.
it down.
But so it would seem odd to me if we have one set of mechanisms for this and a completely different set of mechanisms for multipath. That seems slightly complex.
So
but let's have the discussion.
It sounds like you need to be involved in that design
There you
team,
go.
perhaps. Yeah.
So the other thing I'll point out here is that there's a question of how do you support basic NAT binding. And I don't think that's fully supported with the current text either, because we need to be able for the server to validate the client,
Correct.
and that's not there.
Correct. So we need some things for V1, like monetary binding and some
Yes.
form of migration. Yes.
Okay. Thank you, Jana.
Thank you.
So next up, we've got a little less than a half an hour left. And next up, we've got a discussion of the third implementation draft. And I don't know if we're going to hammer it out all here, but it would be at least be nice to start to kick off that discussion and figure out what we want to target for interop in Melbourne. We have a full day of interop scheduled at that interim meeting. And we may even, like we have in the past, use this target for the next interop beyond that. And I guess there's an assumption baked into that we're done with the second implementation draft. And so I'd like to hear feedback, especially from the implementers and the people at the interop, as to whether they think we're done with the second and we're ready to start shaping a third target for interop, and what that might include. Go on, Ecker. And there are stickers yet again.
I'll put the speakers in the back. But I'm also in line.
Oh, well, you could have just talked, man.
Also,
Yeah, right. So, I think we're not done with the first implementation draft in the sense that we're pretty far from people having interop on all the features that you could potentially have interop on. But I don't think that's really a useful benchmark for what we should do. There really are two things you might imagine doing, right? One is saying, well, we're going to make a much more filled out test matrix for the second implementation draft and just target no new features, but just filled out test matrix. And the other thing you could do is you could say, well, we're going to target a bunch of new features, but the same crappy quality of implementation testing. I think ordinarily I'm a conservative person, and I would say let's fault the test matrix. But I think that given the conversation we had yesterday, I think trying to get some experience with the things, any experience at all with some of the things we haven't done yet, would be valuable. ZeroTT in particular would be nice. So I think my sense is that we should pick out a small, manageable set of new things that we think should be in the third implementation draft, and say that plus whatever is in 08 basically now we should do. And I think Martin's got a thing, right? So this is the second draft, right?
Yeah, this is two.
So didn't we have a bunch of crap that didn't make it on the island? It was things. Yes, there we go. Good. So if I had to the things that I would think, as I say, I think ZeroTT should absolutely be on this list. What else? I'm starting to get pretty sad that we don't have no one's really testing congestion control. But I mean, it's pretty easy to design a protocol that doesn't have congestion control and just to get some data across the internet. I guess I would say either loss recovery or congestion control or both. I mean, basically, be able to demonstrate that you can demonstrate that you can, phrase it differently. Demonstrate that you can move concurrently a fairly large amount of data under more or less ideal network conditions. Because we're already seeing scary stuff where people try to do this and it doesn't work. I'm not even sure I'm correctly giving out stream credit, for instance. So I think those would be the two things I would be inclined to think about. There's still a lot left, so okay. Even if we don't do those, even if we do those things.
Ian Sweat, Google. Yeah, I agree. I think 0 RTT is definitely on the list, and if we don't do that now, that's kind of crazy. And yeah, I think we don't need to do all of loss recovery if we don't want to. If we just want to tack fast retransmit onto the existing RTO stuff, I think that's totally sufficient in my opinion. And then I think congestion control, especially with New Reno, is so damn easy to implement. Maybe you don't get recovery rate, but at least have some kind of AIMD code would be helpful. And yeah, and basically that plus 08 seems fine to me.
Lars Eckert, so the goal for the third implementation draft is Melbourne, right, for the interop, which is not terribly far away. And there's the holiday period in the middle. So it's basically 8 weeks minus holidays. So 08, certainly, I think, meaning variant and all that stuff. I would probably add something along the lines of what Ecker said in terms of make sure you do some sort of, do your loss recovery properly at least. I think that should be stable now. And maybe something beyond just flow control would be nice. If there's strong interest of doing 0 RTT, not sure that I can deliver, but that's okay. You can still add it if other people feel comfortable that they get it done. I would be hesitant to do much more than that by Melbourne. I think it feels like implementations need to settle a little bit longer on this. There's still some that don't really have 07 baked yet, and I would leave it at that.
Is it reasonable to say that we'll probably start at the interim with the third target, but that will continue in London? We've done that in the past, and that seems to work fairly well. More in London. Okay.
Praveen, yeah, so 0 RTT and loss recovery and congestion control seem like good targets. One feedback I would have is loss recovery and congestion control is not much about interop. So, defining very strict test cases would be useful because the number of test cases here just explodes because, reordering, loss, delay, packet delays, there's bunch of test cases. The other useful thing would be that because we're going to be sitting in a room and testing this, having some kind of, software which can introduce these type of defects in the network would be extremely useful. But I think we should very strictly define some test cases for these because otherwise, this is very open-ended.
I will mention at the interim, we're going to be on a wireless network provided by a university. That may naturally provide such opportunities. But if we need to have a wired switch locally, I can provide that. So please ask for it.
So I didn't pay Praveen to say that. At one of these previous events, I spent some time hacking up an interop harness, which basically lets two stations in the same machine connect to each other. And right now, of course, it doesn't have any simulation for any of this stuff, but it'd be easy to add simulation for packet drops or latency interaction. So I think I absolutely agree with you that we should describe rather than saying you must have loss recovery or must have congestion control, we say you should be able to successfully deliver some number of packets, some number of messages of this size on a network with these failing conditions.
Right. Well, we've talked about these more precise tests a few times in the past, and they failed to materialize. So somebody needs to take a pen and write something down.
Yeah, I think that's good enough. Having the requirement that you're able to recover and send a large payload with certain loss characteristics. But one request would be that whatever kind of middle box we're thinking about here, having that a separate box versus loopback would be extremely useful because our implementation runs on Windows. So it would be nice to have a Linux box in between, which is used as the default gateway where we introduce these type of characteristics.
I could probably put together some sort of Docker image or something. Maybe
Yeah.
Lars and I can manage that.
Yeah, Lars, it seems it doesn't matter whether that emulator runs on loopback or not. That's
I agree.
a corner case. I do want to point out that we probably want to have repeatability here. So random loss is nice and easy to do, but I think we actually want to be able to deterministically specify which packets are lost for different test cases, so that you can actually repeat something, which it's a little bit more work to implement, but it's much more useful.
Right. So that's something worth doing. The easiest thing to do is random loss with a specified seed.
Yes.
So that lets you repro once you run into problems, right? That is, you have a random loser, but like he's a way to fetch the seed.
Yes.
I am not I'm prepared to do a number of things, but I think I'm not qualified to describe what a test case would look like with various loss patterns. So maybe someone who really understands transport, like Ian or Jana, could write that down.
Yeah, another point on the random loss versus being able to determine which packet it is, like would be very useful, for example, to drop the handshake packets explicitly.
Jeds, please modulate the amount of time you spend at the mic based on how much you want to talk about header compression.
Yeah. So Martin Thompson, since McManus isn't here, I'm going to push a little bit harder on people. I think we're actually seeing people implement loss recovery now, simply by virtue of the fact that they're running their tests over the internet and they're working. And congestion control, I think we'll see more of as time goes by. I definitely want to get zero ICT and resumption in. We're not going to get header compression now because we simply haven't decided what it's going to be. But I want to be in a position where we're doing
the discussion of that's what's after this.
Yes.
Yeah.
But I want to get us to a position where we're ready to do that as quickly as possible because all the other things are out of the way. And so looking at this list, I think things like the path MTU discovery and key updates are something that can live a long time without actually being implemented. Experience with TLS shows that key updates is not something that people do. But the other parts here, I think I would just move all of those things up into the list of things that we're aiming to do in that time frame. So I think zero RTT, which implies resumption. I think we should have very basic connection ID changes and migration. And I think we should ensure that people have those loss recovery tests working. Sorry?
By Melbourne?
Sure, why not?
Because it's very ambitious.
Yeah, you remember that discussion we had earlier about actually getting this thing done?
I agree. But so, but I also, let me suggest this. Let's try and see if we can order those. And that if you show up with the at the interop and you don't have everything, at least you know that you can do the first three, right, with everybody or with many people.
Right. So my suggested ordering then is loss recovery, since it seems like a lot of people have that already.
08, I think, is the first one, right?
Well,
that's the default.
Sure.
Right?
Yep. Let's do 08. Let's do loss recovery. Okay, 08's the baseline. If we're not doing 08, we're not talking to each other. We're doing loss recovery, and then I would say zero RTT after that, which means that you'd have to test resumption first, which is fairly trivial. Most of the TLS stacks will do that for you pretty naturally. And then I think people should be moving on to migration. I don't think that taking it explicitly off the table at this point is a good idea because we need that sort of momentum. And it's not actually all that much. Did we have stateless reset in this list?
I think we had stateless reset. We had.
Yes, we do. Okay. Yeah. Those probably need to be slotted into the list as well. A hello retry request, those sorts of things. I don't know that there's much evidence of people actually doing these things.
They were not really tested much.
Let's slot those into the list as well. Probably after loss recovery and zero RTT and hello retry have gnarly interactions. So I would put one or the other ahead. I put them adjacent to each other.
I missed that Martin Duke is actually in line, and I don't know how long he's been in line.
He was behind Ian.
Okay. One thing I want to mention that for the second version of this, Martin put the wiki together and sort of helped. And I would specifically want to ask for somebody who isn't an editor to do the same thing for the third implementation draft. It's probably going to be more work than Martin had to do for the second implementation draft, but because we need more detail and a bit more rigor now. But I don't want to put this on the editors because they have other stuff to do. So if you want to volunteer for this, and I don't know if that's what Martin's in the line for, but if we'd be happy to hear from you.
Ian Sweat, Google. I generally agree with actually what you just said, what Martin just said. Sorry. Although I would say that I think we should keep the HTTP 0.9 option available and not force everyone to move to the HTTP2 mapping, given doesn't have header compression and it's a fair amount of extra work compared to all the other stuff. I would rather see like people get like almost everything else done except for the mapping, and then do the mapping later. So I don't want like people that come there with like hacked up terrible HTTP2 mapping implementations and no zero RTT. Like I would rather have people like have a fully formed transport and like still be doing 0.9. And the other thing I wanted to say is I would suggest that we move to TLS draft 22, which I believe doesn't actually exist yet. Yeah, because like it's annoying the ever-loving crap out of our boring SSL team that we still have to deal with 21, and it's annoying to them. So if we could possibly move to 22, that would be like hugely helpful for us.
Can you repeat that at the mic, just for everyone else?
I mean, 21.7 was basically the target of like most of the work on Saturday and Sunday. So I think all the stacks that people are using already have some proto 22 in them. So we're pretty far along on that.
Martin, go ahead. Martin Duke.
Oh, sorry. Yes.
Martin, we can't hear you. And I have pressed the button.
Yeah, it thinks that he's speaking, but.
Yeah, meet echo. Hello, hello.
Or it might be a microphone problem on his part. Martin, do you want to try and maybe type it into Jabber and we can relay it into the room?
All right, Jana, go.
Jana, I generally agree as well with what Martin said, and I also agree with what Ian said about the HTTP2 mapping or the HTTP retaining the 0.9 mapping. I'll just say to one minor point about loss recovery that I think it'll be useful and perhaps important to have losses that are not random, in fact, because I think we're not testing for performance. We want to test for specific cases, and being able to do that with specific packet drops instead of random drops is going to be more useful.
Martin Duke. Two things. I concur with the basic consensus for zero RTT, loss recovery, congestion control, and still typing.
Do we have somebody who would consider being the stackee to maintain this third draft wiki page and sort of?
Ecker. And also, I have some code to drop specific packets in a connection that I might be able to contribute.
Oh, that's excellent. All right, thank you, Ecker.
All right. So we'll create a wiki page, a third implementation target. You put the general shape in there, and then if you can also try and drive people to contribute some form of more specific tests, and think about what format that might take, that'd be fantastic. I don't expect you to come up with them all.
Do I have the chair's permission to nominate people myself to do that work and then hassle them when they don't?
We will transmit all of our terrible powers to you.
Yeah, but don't pick the editors if you can avoid it.
Obviously not.
Right. Thank you very much, Ecker. Really appreciate it. Okay, so that is the third implementation draft. We'll get that up for discussion as soon as possible so people can start coding and working on tests. The last item we had on the agenda, and we only have 10 minutes left, is issue discussion, and I think the issue we want to discuss before we leave the room is a roadmap forward for header compression in HTTP. We had two proposals that we've been discussing for quite some time, and we seem to be moving towards convergence in Seattle. And then we've had a third proposal made, which I think from a the perspective we're at now, especially with our, you haven't read it. I've glanced at it. I think the what we want to try and do is to converge our proposals, so not have additional options, but move towards a single option. And so I think what Lars and I need to do is to have a discussion with the editors or the authors of all those documents and figure out how we can move them forward to a single proposal for the working group. Any comments on that and any discussion that we want to have right now? I see a thumbs up that I'm transmitting to the mic. I see 2 thumbs up. Mike.
So Mike Bishop, well, this is a short microphone. All right. Mike Bishop, Akamai, author of one of the drafts in question. So in Seattle, we had asked Buck and me to go and form a design team. And for reasons which many of you know, I have had 0 time to do that. So I'm sorry, I have not touched that. My intent was to try and get some time scheduled for us to spend that up this coming week.
Okay.
So hopefully we'll have some answers there. I think we did get at least some reasonable takeaway from the interim in Seattle of there's willingness to move away from HPAC if we HPAC's wire format if we get some benefit in return, but we're not committed to that. There is definitely a preference to move the complexity to the encoder and away from the decoder and keep it as dead simple as possible. I think right now those are our guiding principles on how we merge.
So in the discussions I've had, I've heard a strong desire for us to be able to choose a draft to adopt for header compression in the next interim. So I think we need to direct all of our efforts to making sure we're able to do that by the next interim. Doesn't mean that that will be the exact thing we walk out of with an RFC, but we need a starting point for it.
Yeah, so Martin Thompson, I observed that most of the drafts and even the new one are similar in very many critical ways, and they diverge on only a few key points. But the principles that Mike just elucidated should help us. I've heard people express this week, particularly in light of the discussion we had earlier in the previous session about schedule, that perhaps things like delete we discussed taking it off the table before, but perhaps we might reconsider the option and reconsider the notion of just saying, well, deleting is actually the only really hard part in this one. Maybe we just take that out and put it down quietly and move on. So that's a discussion I think that we should possibly have maybe now. I don't know. Do we have the time?
We have 8 minutes, so
yeah, no, not really. Yep.
I would say if Mike, if you can work with Buck and come up with a combined proposal that we can discuss in the list in the next couple of weeks.
Please also include Dimitri. I think
Sure,
that would be
I think that would be how.
unfair.
If you guys are okay with that, that'd be fantastic.
Yeah, so I had actually hoped to have some meetings this week, but it turns out I'm the only one of us that's here. So.
Sorry, I didn't catch it last.
I had hoped to have some of those discussions in person this week, but it turns out I'm the only of any of us that's here.
Okay. If there's anything we can do to facilitate what you need to do, please ask. And hopefully we'll have some discussions on list. We're going to reserve a chunk of time in Melbourne to do this. Okay, great. Do we have anything else we can discuss in the next 6 minutes? I don't think so. So let's call it a day. Thank you all very much.
Grab a sticker on the way out. They're on the tables on the left and right.
Also talk about well, exactly. You know, this is not Christmas.